I'll be presenting about a function not equivalent to its Taylor series. As a reminder, the Taylor series of a function is an infinite polynomial constructed with coefficients of this form. Typically, the way the series is constructed makes it converge to the function used. However, this is not the case for some functions, as will be shown today. In this presentation, I'll cover one specific example of such a function, describing how one could find it and why it works. The most obvious way that a Taylor series of a function cannot converge correctly is if somehow, at a single point, say x equals 0, the value and all derivatives of the function are 0. In this case, the Taylor series would just be 0 as well, while the function itself can proceed to differ and have non-zero values at other points. With that idea in mind, we recognize that we are looking for a function that has the same value no matter how many derivatives you take, which places exponential functions into the spotlight. Finding an argument that would make the exponential function 0 at x equals 0, we can simply consider the argument negative 1 over x squared. For continuity, we will be taking the limit as x approaches 0 to determine what value the function and its derivative should have there. When taking the first derivative, we get a coefficient with 2 over x cubed, leaving the exponential that dominates and produces the value of 0. This is true for any number of derivatives, since the coefficient is always a polynomial with negative exponents, which becomes dominated by the exponential. Thus, the Taylor series about x equals 0 would result in just 0, which is clearly not equivalent to the function itself. Here's a graph of the function and the first two derivatives. As you can see, they all rapidly approach 0 as x approaches 0, producing the desired behavior of the Taylor series about that point. The conclusion one may draw from these examples is that the Taylor series are not as versatile as one may expect them to be, with there being exceptions to the rule and a necessity to check whether the case you are working with actually allows a particular expansion to be used.